In the spanning tree protocol universe, each switch port has a state and a role. Imagine the state as what the port is doing right now, whether it's forwarding frames, learning MAC addresses, or just sitting there not making a fuss. On the other hand, the role is about what the port's supposed to do at the STP party. Is it the headliner path to the route, a reliable designated forwarder, or just a backup dancer hanging out backstage? Confusing states and roles is a textbook exam mistake. They're related concepts, but definitely not identical. IEEE 802.1d gives us 5 port states in the spanning tree protocol, so let's walk through them. Starting with the blocking state. Picture it as a nightclub bouncer. It hears all the chatter, receives BPDUs, but isn't letting anyone in or out, doesn't forward frames, and isn't keeping a guest list, doesn't learn MAC addresses. Its main job? Keeping those pesky network loops at bay. Next is the listening state. This one's like a committee member in a meeting. It's all ears, participates in BPDU exchange, and gearing up for a vote, STP election, but still not opening the floodgates for traffic or collecting any MAC addresses. Moving on to the learning state. Imagine a student cramming for an exam, not quite ready to dive into action yet, still not forwarding frames, but busy taking notes, building the MAC address table from received frames. This groundwork helps minimize the chaos, flooding, once traffic starts flowing. Then we have the forwarding state. Here the port is finally in business, smoothly passing frames like it's been waiting for this moment. And finally, the disabled state. Think of this as a port on a holiday, completely switched off and inactive, all thanks to the shutdown command. When a port first powers up, it kicks off in the blocking state. Imagine it like a nightclub bouncer, standing there, deciding who gets in. If the spanning tree protocol gives the nod that this port is part of the main event, whether as the designated port or the root port, it shifts into the listening phase for 15 seconds. Think of this like a traffic officer getting ready to sort out who goes where on a busy intersection. During these 15 seconds, the STP election is in full swing. Then the port moves into the learning phase for another 15 seconds. Picture this as the port getting acquainted with the guest list. Essentially, it's learning the MAC addresses to fill out its table. Once this study session wraps up, the port reaches the forwarding state, and data can zip through like it's on a freeway. But if something happens in the network that requires the port to stop traffic again, it jumps right back to blocking without delay. Now, if port fast is in play, it's like having a backstage pass at a concert. The port skips the whole listening and learning phases entirely for access ports. Let's dive into 4 common snares when it comes to port states. Kicking off with blocking and listening, these two might look like identical twins since neither is pushing through data frames. But here's where it gets interesting. In blocking, the switch is keeping mum on sending BPDUs from that port, whereas in listening, it's quietly sharing those BPDUs. Think of it as the difference between just observing in a library and whispering insights to a buddy. Moving on, port fast is like your access port's trusty sidekick, but keep it clear of trunk or switch-to-switch links, unless you want your network to throw a loop-to-loop party. Third in line, a port in the learning state is akin to a student who's absorbing a lecture. It's processing frames, but they're not heading out just yet. Lastly, our good old state machine jumps into action with the arrival of BPDUs. If a blocking port stops hearing BPDUs and the max age ticks by, it shifts to listening, preparing to reassess its situation. So those are the STP port states: blocking, listening, learning, and forwarding. We talked about what each one does and how PortFast lets you cut in line. Keep honing those CCNA skills at Courseiva.com. Good luck and stay curious.